So, what is called Gaussian elimination. Okay, it is elimination kind of to the next degree. So now we've got, technically they're considered linear functions because there's no x squared, but there's three variables. Okay, three equations, three variables. So, again, Gaussian elimination is just elimination to the next degree. That's really the best way I can explain it. The first thing you're going to do is take the first two equations, put them on top of each other. So 2x plus 2y plus 3z equals 3, and then put the second equation underneath it. And then you'll take the second and the third, so you'll use the second equation twice. Put it over here. Anytime during this process, if I lose you, you need to stop me. Hopefully I have not lost you so far. Okay, then within each set of systems now, so you kind of see it as we have one system over here and another system over here. We have to cancel the same variable. Okay, so if we cancel the x in this one, we've got to cancel the x in this one. If we cancel the y over here, we've got to cancel the y over here. On this particular one, the x is going to be the easiest to cancel out. So over here, if I have 2x and x, okay, and if this is 2x, I need to make this x what? Negative 2x. So I'm going to multiply that whole second equation by negative 2. Now up here on the screen, I'm going to rewrite the first equation so that I can write them one on top of the other. But then I'm going to multiply the whole second equation by negative 2. And then go ahead and do that next step. So my x's will cancel. 2y minus 6y is going to give me negative 4y. 3z minus 4z is going to give me negative z. 3 minus 10 is going to give me negative 7.
But wouldn't 3z times negative 2 be negative 6z?
I multiplied the second equation. Yes, ma'am.
So if you multiply on the first set of equations, if you multiply the x, you can't multiply the y in the second set of equations.
Say that again.
Like on the first set of equations, like the first two, if you multiply the x and like cancel out the x, you can't on the second set of equations, you can't cancel out the y.
No, that's correct. So since we canceled out the x's over here, we would need to come over here and cancel out the x's over here. Okay, so to do that, Tan, what would I need to do to cancel out these x's?
Times the first one by 3.
Okay, if I do it by 3, I'm going to have 3x and 3x. So what is negative 3? So since I'm multiplying the first equation, I'm just going to multiply and write it right underneath that second one. Okay, just as long as I've got the two that I'm working with right on top of each other. Yes. Let's finish this problem first. Once we do that, and now we have two equations, we are going to take these two equations that we have now, and we're going to make a system with them. So I'm just going to write that one right here, that way I have some room underneath it to work. So I would have negative 4y minus z equals -7. And I'm going to put that one right here. -8y minus 5z equals -11. And now, this is just like the elimination that we had last class. Two equations, two variables. Okay? So looking at this, Manny, which variable do you think you would cancel if I gave you this problem?
Y
Okay? What do I need to do to cancel out the y?
multiplied by -2.
Multiply the first equation by -2. So that's going to give me 8y plus 2z plus 14. Or equals 14, sorry. Bless you. My 8's cancel. I have -3z equals 3. So what does z equal? -1. Once you have that, okay, once you find the first variable, the value of it, now you have to kind of work back through your work, plug it in to get the other values, okay? So I'm going to take that -1, just because there's nothing really written on it. I'm going to plug that into that equation right there, without the -2. So I would have -4y minus -1 equals -7. Negative times -1 is +1. I would subtract 1 to get -8. And then whenever I divided, that would give me that y equals 2.
Does it have to be like a specific one of the equations you plug?
Nope. No, I could have put this negative, really I could have put it into any of these three. Okay? So now I'm going to take both of these, and as far as the ones that I usually pick, I try to find the one with the least number of coefficients. Okay? So now that I have z and y, I need to plug it back up into the original 3. And that third equation right there, that has y and z, neither one of them have a coefficient, so in my mind, that one's going to be the easiest to work with. So I'll have 3x plus y, which is 2, plus z, which is -1, equals 4. Okay. That's going to end up being 2 minus 1, so 3x plus 1 equals 4. I'll subtract 1 to get 3, and x equals 1. Questions on that process? Yes.
Which equation did you put that?
So 3x plus y, which y was 2, plus z, which z was -1. Questions on that process? We won't have time to go through all of the second one, but we're going to do that first part where we split it up into two. and go through that process. Okay, because once we get here, once we get to this part, that's just like last class. Okay, and if you're still struggling from that point, you need to come in tutorials. Okay, so let's go down to number 2. So first thing is I'm going to split those up kind of into 2 subgroups. Okay, so looking at these, Hannah, which variable do you think would be the easiest to solve for?
Y.
Y. Okay, so on this first set over here, what do I need to do in order to cancel out Y?
Multiply it by -4.
Okay, I'm going to multiply the second equation by -4. Again, I'm going to rewrite the first equation so I can have the 2 right on top of each other. So it should end up with that, and then that would give me this equation right here. So going to the other set, if I need to again cancel out Y, Jillian, what would I need to do?
Multiply by 2.
Okay, first or second equation?
First.
Awesome. So I'm going to multiply that by 2. So I got 14x minus 2y minus 6z equals 40. And we have more time than I thought, so we're going to finish this because we need to see a problem like this. Yeah, go ahead. A lot of times on these Gaussian elimination problems, the numbers will get a little bigger than we're used to, but looking at that is about which variable, x or z, do you think is going to be easier to cancel? Z. I would usually go with the smaller numbers. Okay, in this problem right here, you're gonna have to multiply both equations. Okay? So I'm gonna multiply the top equation by -2. If you gotta go to Kate Center, make sure you grab a homework before you leave. And I'm gonna multiply the second equation by 13. Alright, so that's where you should end up. So I would end up with 247x equals 741. And that, whenever I divide that by 247, x equals 3. So now I'll need to go back up into the 2 by 2, okay, 2 equation, 2 variable problems. I'm going to do this one because the coefficients are smaller, and the math will be easier. So I'll have 15 times x, which is now 3, plus 2z equals 41. That's going to give me 45 plus 2z. I'll subtract 45 to get -4, and so z equals -2. So again, once I have those two answers, I'll take both of those and I will need to plug them into an original one. Again, that last one, the numbers are kind of small. They're all positive. So I'm going to use that one. You could use whichever one you wanted. So I've got x plus 2y, which I don't know y yet, so I'll leave y in there, plus 8z, which z was -2, equals 1. So I need to simplify it down. Oh. And whenever I solve for y, I get that it is 7. Okay. Questions on this?